Deep learning and AI has an increasing relevance and growth in many sectors. And as the technology advances and offers ever faster time to results and greater depth of insight from data, the crucial role of optimized storage can often be overlooked. Having over 25 years of data management experience, our partners NetApp are experts in this area. And in this video, our AI specialist Mark Klarzynski talks to Jack Watts, AI leader at NetApp, about evolution, challenges, case studies, and NetApp's hybrid multi-cloud environment.
Hello, I'm Mark Klarzynski of Scan Computers, and today, along with Jack Watts of NetApp, we're going to talk about the importance of data mobility within the AI project lifecycle. Jack, maybe you could start by introducing yourself and your experience.
Hi, my name's Jack Watts and I'm the AI Business Development Manager at NetApp. My role at NetApp is really to look after our customers and partners. But today we're going to discuss some of the challenges that organisations are facing in the artificial intelligence realm.
Jack, you've been in the industry for a while. Maybe we could start with a brief introduction, explaining how you've seen AI evolve over the years.
Absolutely. So I've been in the industry for coming up to 6 years now. Back when I started at NVIDIA, I looked after the channel and partners like Scan actually. And at that time, there was a lot of the development at very early stages. We came out of this AI winter and now we're into almost like an AI summer. If you think about it like this, customers as data scientists were actually starting to develop in gaming PCs. So they would use an off-the-shelf GeForce GTX GPU inside a pretty powerful gaming rig, essentially. They'd then install Linux, their driveries, libraries, dependencies, all kinds of elements before they actually start then installing that framework. And that's the toolbox that essentially what they use as their model development area, if you like. And then what essentially they do is, they take their data set, click train, and then move on. That's now moved to organizations using up in the cloud. They're building out their own AI platforms, installing in data centers. It's absolutely exploding.
We've had so many expectations with AI over the years. Are we beginning to see real-world solutions, maybe within the healthcare sector or even the local supermarkets?
Absolutely. So some of the industries that we're starting to see real AI going from that early days of proof of concepts now into those piloting phases, if you like, the alpha beta testing that's being done and now being integrated and deployed in actual systems in real life. In the medical sphere, it has been various challenges around it, and it's largely around the available data sets. So there's been research institutions coupling up with hospitals. There's one example that I'd like to talk about later, one of our mutual customers, of course, King's College London. But essentially, when it comes to taking that patient data, having it annotated already can be a challenge. Then curating that, getting that data prep done, feeding it through a neural network in most cases, backed up maybe even with some machine learning involved. It takes a lot of time to actually get to that stage. And when you look at those collaboration between universities, between medical institutions, the issues that these guys face is around the fact that they can't share data. You mentioned also supermarkets, and supermarkets are really quite interesting because you think about walking around a supermarket today, you don't think you're being watched, so to speak. There's not this element of Big Brother in that way. But if we think about supermarkets today, they're wanting to understand more about how their customers travel throughout their stores, how their customers interact with end bins, interact with shelves, so that they can actually give that data back potentially to manufacturers or further optimize how their store layout is phased. When we then look at things like self-checkout, that's where it becomes really interesting. There's been some sneaky people out there that have realized that maybe a bunch of bananas will weigh the same as a bottle of wine. So take a label from a bunch of bananas, stick it over the label on the bottle of wine, scan that barcode, put it in your basket area, and then suddenly, you've got a very interesting problem where people are buying bananas, lots and lots of bananas. I think there was one use case in Australia where there's a lady buying everything and all she was buying was lots of different pasta, but of course she was buying her entire grocery shop. So the challenge around that is that you have to not only have a camera looking down at the self-scan area, you have to have behavioral analytics almost in the customer sense, and all within milliseconds you have to understand the barcode that's been scanned, check the pricing's right, check the weight of the item is right, and then visually have that checked as well. You might say, yes, bananas look completely different to a bottle of wine, but of course different bottles of wine carry different pricing, carry different, various different elements around that. So you have to look at the label, and there's various complexities around that. The most complex one, however, is actually women's makeup. So I'm a huge wearer of mascara, and I didn't know this, but apparently there's different prices of different mascara and there's different available ranges. If you take one mascara from one vendor, it might cost say £1, £12, I don't know. There might be another one that's costing £30. Quite easily, customers could potentially manipulate the system in the way that I mentioned earlier. But then how do you look at that sort of almost at a macro level, that particular eyeliner or that particular mascara or whatever it is, all in milliseconds? It's just the amount of data that's being generated and then needs to be trained in neural network models around that is absolutely staggering.
Okay, so what we're beginning to see is AI being implemented to solve real-life business challenges.
Yeah, absolutely. And, there are various business challenges. So in the retail setting, it's shrinkage, right? If you look at £50+ billion being spent in the UK every year and in retail setting, maybe not so much if you look at what's happened over the last few months, but certainly if you take around 4% of that is lost to shrinkage. And shrinkage is, of course, things like shoplifting, missed POS scans, stuff going missing from warehousing, or just kind of those different EPOS and various ERP systems that are having those kind of conflicts. That shrinkage problem is huge. And when we think about that with customers and they say, look, we seem to be losing a lot of this product, or we seem to be losing a lot of that product, it then has to be given and comes down from the line of business into that data science realm where those guys are being asked to solve this problem. And then they think, right, okay, so where now do I get my data from? It might be product shots of images, it might be product shots of barcodes or various other elements. The challenges around that are largely in terms of the actual data set preparation. And this is where data engineers come in.
Okay, following on from that, when the data scientists start a project or an early proof of concept, we would not expect at this stage significant hardware investment. This would seem the perfect model for cloud.
I think it's amazing today that you can go to any hyperscaler, enter your credit card details, and instantly spin up a GPU-based resource and attach some pretty mean and lean storage to it. When we then look at what that gives you as a data scientist, it gives you just a blank box, right? You have to, again, work up from bare metal and go to that framework layer. But the interesting piece there is that you can obviously look at the costs very closely. When it comes to cost, if you want to be able to do repeating experiments, if you want to be able to keep doing that, your boss or your financial director is going to come to you at some point and say, spending a lot there on the hyperscaler, is there any other way that we could be doing this? And really that's where the first part of exploration happens. That first proof of concept can be done in the cloud. And then when you want to work on more meaningful data sets, you may actually want to pull that model down, pull that data set down, or pull in a larger resource of data sets that you have in your core data center, or even at another ingestion point, and then work on a more meaningful data set to go through that piloting phase. You may then also want to actually compete models against each other. And that's really where that fail fast and learn faster really comes into it.
So we are saying simply start on cloud and move on-prem as more power and data is required.
In most cases, yes. And I know for a fact, Scan, of course, have got a fantastic business around building these developer workstations with one to many GPUs inside. This is where that next stage of experimentation comes along. But again, if data scientists are still working from that bare metal layer up, they're not necessarily designing with optimized with that optimized container or an optimized fashion right away. And that's where customers are now starting to leverage the NVIDIA GPU Cloud. The NVIDIA GPU Cloud is an optimized framework arena, if you like. I loved it 5 or 6 years ago when I only had to remember five or six frameworks off the top of my head. There seems to be a new framework every week. So when it comes to NVIDIA actually optimizing that from the Linux kernel upwards to the framework, giving the ability for a data scientist then to just scale instantly from a PC, from cloud, onto a data center scale system, that's really powerful.
Okay, the logic for transitioning from cloud to core is clear, but now we introduce the challenge of migrating the data.
Absolutely, and that's where organizations are facing challenges around these kind of data silos. So, if you've got people going out on their own and doing this all exploratory experimentation, they're creating their own data sets effectively and may be adverse to IT policy or adverse to the overall IT strategy of the organization. Challenges there really present themselves when it comes to actually leaving a hyperscaler and coming down to a core system or going over to an edge-based system. That's where data fabric comes in. The concept of data fabric is the ability to have your data where it needs to be computed in this case, or ingested. It could also be that you want to be able to work with a hybrid multi-cloud environment. Now that's an incredible strategy that NetApp have been able to deliver over the last few years. Working with all the major hyperscalers, you have NetApp systems and NetApp software in the cloud today, with different feature sets and different, obviously, performance packages available. That gives the ability and flexibility really to the data scientist or to the organization, so that if they need to pull data together in the cloud, pull it back down to core, move it between clouds, they have that complete availability and that complete possibility of being able to do that. Everything with ITI on the end.
So by choosing to select NetApp with your cloud provider, you start within the NetApp ecosystem and have full data mobility when you need it?
So we have Cloud Volume Services and Cloud Volumes on tap with the majority of the hyperscalers, or if you like, Azure's NetApp files. So the ANF system is incredible. That's a first-party relationship that we have with Microsoft, and we're really pleased about that. What that enables the customer to do is be able to go through and between clouds very easily, but then also be in control of their data, because each hyperscaler has their own interpretation of how you should manage your data. And that's where, if you have that just single pathway, if you like, to managing your data, it makes it ever so much easier. And if you make that concerned choice, and really consider where your data then needs to be moved to, or where you need to move your models to, or where you want to have your employees manage and manipulate data, create data sets, move data sets, then making that choice right at the beginning is quite important.
Okay, Jack, we've talked about cloud to core. Maybe we could talk about data on the edge. Actually, maybe you could outline what you were seeing at the edge?
Edge is certainly one of the most exciting elements of AI today. OEMs out there are producing really niche-y, quite pizza box style almost, edge-capable devices, integrating the latest NVIDIA elements within that. What we're able to do is actually port our ONTAP Select software onto those systems from an x86 perspective, and have, again, that coupling of data between core, between cloud, over to the edge. Because edge is where really companies want to be able to either ingest data, maybe even do some kind of data cleansing and preparation there before you would need to have a huge amount of bandwidth to get that back to your data center. If you do some curation and prep and maybe even trim that data set down, if you're looking at trimming the tree and being able to trim the fat, if you like, to bring that data back to your core systems, there's features available within our software that enable you to do that within a very lean sense. But then you're still pushing and pulling between core and edge there. So if you've got ingest coming in, you've then got the data that's been prepped and then is going through your main environment. If you then think about, once you've got your model created, being able the flexibility to just cache and push that model back out again to the edge as and when required, because you've got to think about model revisioning as well these days, and that tracking and traceability of that model, linking it to the data set. When it's at the edge, that's where you want to also do that inferencing. So let's talk about some edge cases at the moment. So edge cases could be predictive maintenance. So whether it's vehicles on the road from a municipal point of view, it could be manufacturing machines producing pills, producing clothing, fabrics, to be able to predict how a machine is operating in a gold standard. And then if one part is not operating so well, then it might affect another part, and so on and so forth. To be able to intervene and go and actually change that part before it starts affecting others really helps organizations keep their machines in a more 999 uptime. All the nines is what the organizations want. If we then think about CCTV or smart cities, edge devices now are capturing video data. In some cases, in most countries, certainly in Europe, it may be that you actually need to obscure the face before that data is actually transferred back to your core location. But they're still wanting to look at behavior analytics, doing some cropping and various other tasks that can be done at the edge to essentially create a much leaner data set or a much leaner data stream going back to that data center. I'm really excited to see what other companies come up with for edge-based use cases. But some of the coolest ones are certainly in the automotive industry, or even in autonomous vehicles in general.
What is interesting, Jack, is that normally with storage we talk IOPS, bandwidth, scale. But what I am hearing is that NetApp have focused not only on providing the performance, but also a much wider solution that deals with the entire AI journey and life cycle.
I think that's a really interesting question, and my answer to that would be that you're absolutely right. There are a lot of storage vendors out there. We're not the only guys in the realm of NVMe flash-based systems. You know, we've got fantastic software writing ability. We've got features, we've got patents, and similarly other companies do too. But it's how you actually leverage and integrate within a partner ecosystem. You know, if we look at NVIDIA, one of our closest partners in the AI space from an infrastructure perspective, we've got fantastic partners like Scan that are able to bring all of these elements together to actually deliver down to a customer site. Because it's not just necessarily the infrastructure team that's needed. You know, we can provide the fastest data layer into the compute systems, no problem. We can then actually, what we've done with our AI control plane, for example, is we're now orchestrating and provisioning the GPU, the compute resource, as well as the storage and bandwidth required from a networking perspective to a data scientist, to a data science workload, to a particular job, so that those can be leveraged in the best and most efficient way.
Okay, Jack, we've covered the challenge of data mobility. Let's hear a success story. You mentioned KCL earlier.
King's College London is a fantastic example of really a partner like Scan bringing together an ecosystem of infrastructure providers, software vendors, and of course the right tools in the chest, so to speak, to take to a customer where they had that challenge around preserving patient data. Now this is where I mentioned earlier about having a good standard of data set, a good annotated data set. So when it comes to cancer imagery, for example, radiology is essentially a dying trade. A lot of kids today aren't necessarily going to college or university to learn radiology, learn how to detect cancer. So this is really where AI can come in and really empower the radiologists that we have today. So King's College London had a problem where they wanted to get a really good standard of a machine learning model and deep learning model trained for various cancers. So they started off with several million data points that they could train a machine learning model with, and a deep learning model that they can then essentially deliver that model down to a clinical institution. When I say clinic, I'm talking more of course around a hospital. That hospital can instantly start inferring from that trained model. What they then can use is a technique called transfer learning, where essentially they take the data points that they already have annotated themselves and then retrain that model. That model can then be transferred back to King's College London, for example, where they will then curate all of the model's changes that have come from various hospitals and various trusts perhaps, and then essentially create a master model where you have more than several million data points all collected, all created and trained in a very secure fashion. And that's no transfer of patient data. I must be clear on that, because that's of course what these hospitals and trusts today can't share between each other, especially when it comes to patient imagery. So I think that's a really interesting use case, and federated learning is really becoming this kind of blueprint for institutions in both at public and private organisations where they wish to, of course, have that better standard of accuracy when it comes to cancer detection. Now you might ask, what is the business outcome? I'm spending all this money on compute and storage and networking. I've got a great partner like Scan that I can work with, and we can all sing and dance about it. But the business outcome really is actually improving that patient pathway. When I talk about patient pathway, we're talking about a minimum age of when you would go for a particular screening of a particular cancer. We can then start to look at lowering the age of those mandatory scans, if you like, or recommended scans, so that we can catch cancer earlier, increase the number of scans that we're able to do, because you can say with a degree of accuracy that scans are clear. It's those scans that aren't clear that need, of course, a review by a radiologist. And if a radiologist is looking at 100 scans a day, and touch wood that only 99 of those are totally fine, it's those 1 to 10 scans that they want to, of course, look at and make sure that they tag correctly and bring those patients back in to talk about that treatment path.
So by effectively distributing the actual deep learning, which has been a collaboration with NetApp, Scan and NVIDIA, we truly are at the stage where we are seeing AI assisting cancer diagnosis.
You're absolutely right. It's all about catching cancer quicker and being able to empower these radiologists and reduce those mandatory ages where you would go for a particular scan. And I think you're absolutely right there that this model essentially starts at that first institution. Once they get it right with several hospitals, it then just starts to scale and ripple out. That's the really interesting thing for me, and I'm really proud that NetApp are part of this journey, and real huge thanks to Scan. I think you guys have got a really good video actually, maybe we can link that below, essentially covering and hearing from the customer why they selected Scan, why they selected NetApp, and really why they love using lots of NVIDIA GPUs, I think.
Jack, thank you so much. I appreciate this has been virtual and we've had 1 or 2 technical problems along the way, but I appreciate the time and hopefully our users will gain much out of this. I look forward to our next.
Thank you to Mark and Jack for taking part in this video. We hope it's helped you to gain some valuable insights into both NetApp and the need for optimized storage in the deep learning and AI industry. And if you're interested in having your storage requirements assessed, then get in touch with the Scan AI team today, who will be happy to help. And to find out more about NetApp and the need for optimized storage, visit the link in the description.